right, so if we zoom in on that chemical reaction, it involves an acid and a base. The acid is from vinegar, acetic acid here, CH3COOH, and calcium carbonate, which we can find in limestone, marble, and pearls. And so the interaction of these two chemicals forms calcium acetate, water, and carbon dioxide. So when you go ahead and if you do this at home, see if you can detect any presence of carbon dioxide. What do you know about how carbon dioxide would be naturally in the environment? You might then see something like a gas or bubbles form around your egg. Okay, so calcium carbonate comes up in the world a lot. We're just going to talk about a couple examples because it's interesting. Pearls are made out of calcium carbonate. What would happen is an oyster starts to have some sort of irritant that comes into its mantle, and it protects itself by forming a nacre layer around the outside, and that is made up of calcium carbonate. So hypothetically, you could maybe also dissolve pearls in acetic acid. You might also see calcium carbonate in limestone karsts. So this picture is from Thailand. There's beautiful structures are formed. You can do some really fun climbing here. Taking some kids out there, that's really awesome. If you're in Arizona, maybe you've been to Walnut Canyon. That's a really good example of some limestone, which is a sedimentary rock that forms when you have, think about the past shells of prehistoric marine creatures all getting pushed down and forming this sedimentary layer. You might also find it in the Great Salt Lake in what is really neat sand particles called oolitic sand, and they look like little eggs. That's the oo means egg. And that's kind of the same thing as the pearl. There is some nucleating force, some little piece of particle, and around it calcium carbonate formed to form these little circles. You might also find calcium carbonate in lime, and not these kinds of lime, nope, and not even this. Have you guys ever done these scooters? They're super fun, but not that lime, but instead for agricultural purposes. And what happens here is you can extract calcium oxide that can be used to take other minerals out of water. That would, if you had hard water, you have lots of minerals dissolved in your water, so calcium or lime can be used to remove that. It also was used to build the pyramids, and it can also be used as a stabilizer when you're making glass. You can also find calcium carbonate in the form of aragonite, which is used to build the bony structures of corals. And just a note here is that as the ocean acidifies, we have more carbon dioxide building up. That leads to a breakdown of the carbonate ions. There's fewer of them available then, because if it's more acidic, right, that's going to break down, just like we're going to see in our eggs as it breaks down the shell. And then actually more CO2 gets released back up into the atmosphere as well. And then to talk about another rock process, metamorphosis, where we have the changing of limestone over into marble. Can you think of what that process is called? What type of rock now is this? So it's not sedimentary, it would be metamorphic. And that's used to build, for example, the Taj Mahal. Okay, so once we dissolve the shell of our egg, we can start to observe osmosis, because what's left is a selectively permeable membrane which is going to allow oxygen to move in and out. And so let's go into our lesson to learn more about diffusion and how this might happen, and then we'll go back and we'll take a look at the results of our experiment.